In this demo, we're going to add an evaluation module to a clustering pipeline in Azure ML Studio so that we can evaluate the results of a candidate model. We'll see how to add and configure the module in the pipeline canvas. Finally, we'll execute the pipeline and explore the results of the evaluation module. Okay, so the first thing we need to do is navigate to the Azure ML Studio using our browser. So in this demo, we're going to piggyback off our previous demo where we created a clustering pipeline that trained a model on how to logically group a data set of penguins based on their characteristics. So let's open that pipeline. Click on the Designer option in the left-hand menu. Now let's select our pipeline from the list at the bottom of the page. Mine was called SBDemo05 Pipeline. Now we're presented with the designer. On the canvas, we've already got a set of modules that do a bunch of things. First, we have a data set that we created based on some sample data from Microsoft that includes a bunch of information about penguins. Then we run that data set through a set of transformers to remove columns, remove some rows, and to bring the remaining data to the same usable scale so that we don't introduce bias into the model training. And speaking of model training, after the data cleansing, we feed 70% of the dataset into a model trainer, which is set up with a k-means clustering algorithm, and the other 30% goes to a module that uses our candidate model to be clustered. So with what we built before, we can easily check to see how or if our penguins were clustered. We do that with the assign data to clusters module at the bottom of the pipeline. But in this demo, we're going to evaluate the results of our clustering. Just eyeballing the clusters doesn't really tell us if it was effective or not. Now, configuring a pipeline to evaluate a candidate model is pretty easy actually. So let's go over to the left-hand panel and search for the Evaluate Model module and drag it onto the canvas below our Score Model module. Now let's connect the output from the Assign Data Clusters module to the left input of our new module. Now that's it. Let's run the pipeline by clicking on the Submit button at the top of the page. Now, in our last couple of demos, we attached our pipeline to a particular experiment. So let's do that again. Let's select the same experiment we've been using. For me, I'll choose the SBDemo05 experiment. Then we'll click Submit. Okay, so as usual, the pipeline may take a while to execute, so I'm going to fast forward to when it finishes. Perfect! Our model has executed successfully. Now let's explore the evaluation results. Click on the Evaluate model if it's not already selected, and select the Outputs and Logs tab. Now notice that there's an evaluation results dataset at the top of the tab. So let's click on the Visualize icon to explore the results. Now we're seeing a number of statistics in this pop-up. First, we have the average distance to other center. This particular metric tells us how close, on average, each penguin in a given cluster is to the centroids of all the other clusters. This helps to tell us how much potential overlap there is between penguins being in their current cluster versus being in another cluster. Basically, this helps tell us if our clusters make sense. Next, we have the average distance to cluster center. This metric tells us how close, again on average, each penguin is to the centroid of its own cluster. And this helps to tell us how good our clusters really are. If the average distance to other clusters is close, but this stat is really close, then it implies that our data might be really dense. Another metric is the number of points. This is pretty straightforward. This is telling us the number of penguins we have in each cluster. Ideally, they're about the same because it implies even distribution, but it doesn't have to be. For example, if you determined a logical grouping of vehicles in a parking garage is their type, then you might have a really small cluster of motorcycles and a huge cluster of cars. That doesn't make the grouping wrong. And finally, we have the maximal distance to cluster center. This metric tells us the maximum of the distances between each point and the centroid of that point's cluster. This metric helps us to figure out how spread out a particular cluster is. If the metric is high, then the cluster would be considered to be widely dispersed. If it's low, then the cluster is pretty tightly packed. So in this case, we can take a look at our metrics, and now we can make a more educated decision on how good our candidate model is at clustering our penguins. Looking at this data, we can decide if our model clusters are in a way that we like them. If it doesn't do a good enough job, We can spend time to make the predictions even better by transforming our data set some more, or even just adding some more data. I mean, remember, we only had 342 rows. On the other hand, if we like our results, then we can go ahead and deploy our model. Regardless, we've successfully run a clustering model and we've successfully evaluated it.